Hello everyone, and welcome to my experiment for the Physics 101 class. The experiment was conducted on the topic of uniform circular motion and centripetal force to analyze and see how velocity changes impact the centripetal force. This experiment aims to measure the minimum amount of centripetal force exerted by a puck, which is on a frictional plane, is needed to prevent a mass from falling, and this mass is connected to the puck by a rope. Let's start by introducing the materials needed for the experiment. Firstly, we need a circular plane with a diameter of 30 centimeters and walls to prevent the puck from escaping the system. Secondly, we need a puck to turn, thus creating the centripetal force. Additionally, we need two masses, of which the first one being 0.005 kilograms and the second one being 0.096 kilograms. Without further ado, let's get to the experiment. In this instance, I threw the puck with a velocity of 0.584 meters per second, and the centripetal force exerted by the puck is 0.954 newtons. As it can be seen, the wooden cylindrical block gets displaced. In these two photos, it can be seen that block has moved downward. The green line represents the initial position of the block, while the yellow line represents the final position of the wooden block. And in this instance, I throw the puck with a velocity of 0.154 meters per second, and the centripetal force exerted by the puck is 0.066 newtons. As it can be seen, the small object with the mass of 0.005 kilograms or 5 grams gets displaced slightly. The displacement is not as noticeable as the wooden block's displacement because of the reduced weight of the small object. It can be seen that green line represents the initial position of the small object and the yellow line represents the final position of the small object. Additionally, it is clear that yellow line is much closer to the green line compared to the lines of the wooden block, simply due to the fact that weight is considerably lowered. And here is a table about varying velocities and their respective centripetal forces, and how did the centripetal force act on the object. Was it enough to lift it up or was it not? As it can be seen, the first three rows of velocities were not enough to lift the object up, so the object fell down. But the last two rows, were just enough to make it lift up. And here is the second table, which mainly is the same thing, but this table is for the wooden block. And as it can be seen, the first four rows of velocities are not enough to make the wooden block lift up. But the fifth one, the last one, is just enough to make the wooden block lift. With some errors happening in the experiment, for example, not being able to throw the puck at the exact speed that is needed for the masses to not fall, or general human errors, the errors for experiments were 35.8% for the small object and as low as 1.4% for the wooden cylindrical block. From this experiment, it can be concluded that velocity and mass both play a major role in the magnitude of centripetal force, as centripetal force is equal to mass times velocity squared over radius of the circular motion. Thank you for watching my project and I hope you have a very good day.